The online Encyclopedia of Integer Sequences, also cited simply as Sloane's, is an online database of integer sequences. It was created and maintained by Neil Sloane while a researcher at AT&T Labs. Foreseeing his retirement from AT&T Labs in 2012 and the need for an independent foundation, Sloane agreed to transfer the intellectual property and hosting of the OEIS to the OEIS Foundation in October 2009. Sloane continues to be involved in the OEIS in his role as president of the OEIS Foundation. OEIS records information on integer sequences of interest to both professional mathematicians and amateurs, and is widely cited. As of the 22nd of August 2015 update, it contains over 260,000 sequences, making it the largest database of its kind. Each entry contains the leading terms of the sequence, keywords, mathematical motivations, literature links, and more, including the option to generate a graph or play a musical representation of the sequence. The database is searchable by keyword and by subsequence. History. Neil Sloane started collecting integer sequences as a graduate student in 1965 to support his work in combinatorics. The database was at first stored on punch cards. He published selections from the database in book form twice. A handbook of integer sequences, containing 2,372 sequences in lexicographic order and assigned numbers from 1 to 2,372. The Encyclopedia of Integer Sequences with Simon Plouffe, containing 5,488 sequences and assigned M numbers from M000 to M5487. The encyclopedia includes the references to the corresponding sequences in a handbook of integer sequences as N numbers from N0001 to N2372. The encyclopedia includes the A numbers that are used in the OEIS, whereas the handbook did not. These books were well received and, especially after the second publication, mathematicians supplied Sloane with a steady flow of new sequences. The collection became unmanageable in book form, and when the database had reached 16,000 entries, Sloane decided to go online, first as an email service, and soon after as a website. As a spin-off from the database work, Sloane founded the Journal of Integer Sequences in 1998. The database continues to grow at a rate of some 10,000 entries a year. Sloane has personally managed his sequences for almost 40 years, but starting in 2002, a board of associate editors and volunteers has helped maintain the database. In 2004, Sloane celebrated the addition of the 100,000th sequence to the database, A100,000, which counts the marks on the Ishango bone. In 2006, the user interface was overhauled and more advanced search capabilities were added. In 2010, an OEIS wiki at oeis.org was created to simplify the collaboration of the OEIS editors and contributors. The 200,000th sequence, A200,000, was added to the database in November 2011. It was initially entered as A200715, and moved to A200,000 after a week of discussion on the seqvan mailing list. Following a proposal by OEIS Editor-in-Chief Charles Greathouse to choose a special sequence for A200,000 non-integers. Besides integer sequences, the OEIS also catalogues sequences of fractions, the digits of transcendental numbers, complex numbers and so on by transforming them into integer sequences. Sequences of rationals are represented by two sequences, the sequence of numerators and the sequence of denominators. For example, the fifth-order Fairy sequence is catalogued as the numerator sequence 1, 1, 1, 2, 1, 3, 2, 3, 4 and the denominator sequence 5, 4, 3, 5, 2, 5, 3, 4, 5. Important irrational numbers such as pi equals 3.1415926535897 are catalogued under representative integer sequences such as decimal expansions, binary expansions, or continued fraction expansions. Conventions. The OEIS was limited to plain ASCII text until 2011, yet still, it frequently uses a linear form of conventional mathematical notation for functions, and for running variables, etc. Greek letters are usually represented by their full names, e.g., mu for mu, phi for phi. Individual terms of sequences are separated by commas. Digit groups are not separated by commas, periods, or spaces. In comments, formulas, etc., it represents the nth term of the sequence. Special meaning of 00 is often used to represent non-existent sequence elements. For example, A104157 enumerates the smallest prime of n squared consecutive primes to form an n times n magic square of least magic constant. Or 0 if no such magic square exists. The value of A is 2. A is 1,480,028,129. But there is no such 2 times 2 magic square, so A is 0. This special usage has a solid mathematical basis in certain counting functions. For example, the totient valence function n phi counts the solutions of phi equals m. There are 4 solutions for 4, but no solutions for 14, hence R of A014197 is 0, there are no solutions. Occasionally -1 is used for this purpose instead, as in A094076. Lexicographical ordering. The OEIS maintains the lexicographical order of the sequences, so each sequence has a predecessor and a successor. OEIS normalizes the sequences for lexicographical ordering, ignoring all initial zeros and ones, and also the sign of each element. Sequences of weight distribution codes often omit periodically recurring zeros. For example, consider the prime numbers, the palindromic primes, the Fibonacci sequence, the lazy-Catarrus sequence, and the coefficients in the series expansion of. In OEIS lexicographic order, they are sequence number 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. A40. Sequence number 2. 2, 3, 5, 7, 11, 101, 131, 151, 181, 191, 313, 353, 373, 383, 727, 757, 787, 797, 919, 929. A002385. Sequence number 3. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, 610, 987, 1597. A45. Sequence number 4. 1, 2, 4, 7, 11, 16, 22, 29, 37, 46, 56, 67, 79, 92, 106, 121, 137, 154. A000124. Sequence number 5. 1, -3, -8, -3, -24, 24, -48, -3, -8, 72, -120, 24, -168, 144. A046970. Whereas unnormalized lexicographic ordering would order these sequences thus: number 3, number 5, number 4, number 1, number 2. Self-referential sequences. Very early in the history of the OEIS, sequences defined in terms of the numbering of sequences in the OEIS itself were proposed. I resisted adding these sequences for a long time, partly out of a desire to maintain the dignity of the database, and partly because A22 was only known to 11 terms. Sloane reminisced. One of the earliest self-referential sequences Sloane accepted into the OEIS was A031135, A equals nth term of sequencing. This sequence spurred progress on finding more terms of A22. Some sequences are both finite and listed in full. These sequences will never be long enough to contain a term that corresponds to their OEIS sequence number. In this case, the corresponding term of A091967 is undefined. A100544 lists the first term given in sequencing, but it needs to be updated from time to time because of changing opinions on offsets. Listing instead term of sequencing might seem a good alternative if it weren't for the fact that some sequences have offsets of 2 and greater. This line of thought leads to the question, does sequencing contain the number n, and the sequences A053873, numbers n such that OEIS sequencing contains n, and A053169, n is in this sequence if and only if n is not in sequencing. Thus, the composite number 2808 is in A053873 because A002808 is the sequence of composite numbers, while the non-prime 40 is in A053169 because it's not in A40, the prime numbers. Each n is a member of exactly one of these two sequences, and in principle it can be determined which sequence each n belongs to, with two exceptions. It cannot be determined whether 53873 is a member of A053873 or not. If it is in the sequence, then by definition it should be. If it is not in the sequence, then it should not be. Nevertheless, either decision would be consistent, and would also resolve the question of whether to 53873 is in A053169. It can be proved that 53169 both is and is not a member of A053169. If it is in the sequence, then it should not be. If it is not in the sequence, then it should be. This is a form of Russell's paradox. Hence it is also not possible to answer if 53169 is in A053873. An abridged example of a typical OEIS entry. This entry, A046970, was chosen because it contains every field an OEIS entry can have. A046970 generated from Riemann's zeta function. Coefficients in series expansion of zeta, zeta 1, -3, -8, -3, -24, 24, -48, -3, -8, 72, -120, 24, -168, 144, 192, -3, -288, 24, -360, 72, 384, 360, -528, 24, -24, 504, -8, 144, -840, -576, -960. -3960, 864, 1152, 24, -1368, 1080, 1344, 72, -1680, -1152, -1848, 360, 192, 1584, -2208, 24, -48, 72, 2304, 504, -2808, 24, 2880, 144, 2880, 2520. minus 3480, minus 576, offset 1, 2 comments B equals B asterisk asterisk, asterisk Z, Z equals B asterisk asterisk, asterisk sum, A, J caret. References M. Abramowitz and I. A. Stegun, Handbook of Mathematical Functions, Dover Publications, 1965, pp. 805-811. Links M. Abramowitz and I. A. Stegun, eds. Handbook of Mathematical Functions, National Bureau of Standards, Applied Math. Series 55, 10th printing, 1972, alternative scanned copy. Wikipedia, Riemann's eta function. Formula multiplicative with A equals 1p squared. A equals sum underscore d n mu asterisk d squared. A equals product p prime divides n p squared minus 1. From John Perry Internet.com. August 24, 2010. Example A equals minus 8 because the divisors are 3 are 1. 3, and mu asterisk 1 squared plus mu asterisk 3 squared equals minus 8. Maple JINVK equals proc local A, F, P, A equals 1, for F inifactors, 2, do P equals op, A equals of asterisk, and do, and proc. AO 46970 equals proc JINVK, and proc. #R, J, Math R, July 4, 2011 Mathematica Mud D underscore equals Mobius mu D asterisk D squared table plus it at Mud divisors N 60 flatten table X equals factor integer N P equals 1 4 I equals 1 I less than equals length X I plus plus P equals P asterisk P N 1 50 1 from John Perry Internet.com. August 24, 2010 Prog AO 46970 equals sumdiv CROSSREFSCF AO 27641 and AO 27642. Sequencing context. AO 35292 A144457 A146975 asterisk AO 58936 A00217 A11858 Adjacent sequences.